Hi guys, this is Snow. Last time we coded Tetris and it went pretty well. So here's another one. In this video I will show you how to code a chess game in Java. Chess is in a sense a turn-based strategy game stripped down to its bare essentials. So if you're interested in developing strategy games, I think chess is a good entry point. So from now I will make it from scratch and show every step. So I hope you enjoy. First, create a project. I'm gonna name this Simple Chess. Then create two packages. The one is main and the other one is piece. And then inside this main package, create a class called main. As usual, first we create a window. So we use a Java class called JFrame and name it window. And we also type the game title here, so it will be displayed on the Windows top bar. This means when we close this window, we also shut down the program. Without this line, the program keeps running even after you close the window. Then we set resizable false, so you cannot resize this window, and set the location relative to null. This means the window will show up at the center of your monitor. If you want it to show up at the top left of your monitor, then you don't need this line. Then we set the window visible, so we can actually see this JFrame window on the screen. That's it for now with this main class. So let's create another class. I'm gonna name this game panel. And this class extends JPanel. So this is basically a JPanel class, but we can customize it. And we're gonna use this class as the game screen. So we set our game screen size here. So I chose 1100 for width and 800 for height. But you can change these numbers if you want. So then constructor of this class. So we set the size of this panel, so we use this width and height, and set its background color to black. Now go back to this main class, and we're gonna add the game panel to this window. So we instantiate the game panel as GP and add it to the window. Then pack it. By packing like this, the window adjusts its size to this game panel. Let's run this program and check it. Alright, so the window shows up. The size is 1100 by 800 and the background color is black. So back to this game panel. And now we add two methods. Like this. And this update method is gonna handle all the updating stuff. Update the information such as piece X and Y positions, or the number of the pieces that are left on the board, or something like that. And this paint component handles all the drawing stuff, drawing the chessboard, chess pieces, and on-screen messages, stuff like that. And what we're gonna do is we call these two methods 60 times per second, so we can refresh the screen. So first we set the FPS. And to run the game loop, we use a thread. To use this thread, we implement runnable interface. If you implement runnable, you are required to create this run method. So this runnable and this run method are kind of a pair. I want to place this runnable method above this update. Just my preference. And now we instantiate this thread. So here we instantiate the thread, then call its start method. And this basically calls this run method. So starting a thread means calling this run method. So that's how it works. Also from this main class, so let's not forget to call this launch game method. So once the window is created, we call this method and start the thread and call this run method. And in this run method, we create a game loop. If you are not familiar with game loop and want to know the details, please check my game loop video or any other resources on the internet. So I'm gonna just type it here. Okay, so this is the game loop, but this is not the only way. There are multiple ways to create a game loop, and basically any game loop is fine here. So if you have your own game loop method, then feel free to use it. So basically this means it calls this update method and this paint component method 60 times per second. So this repaint means calling this paint component method. So now we have a game loop, so let's draw the chessboard. And we're gonna create a new class in this main package and name it board. And this class represents a chessboard. So first we set some parameters. Yeah, like this. So the chessboard consists of 8 times 8 squares, and I set the single square size 100. This means a single square is 100 by 100 pixels, and that means the board size is 800 by 800. I also set this half square size because, yeah, we'll use this later. And here we create a draw method and receive graphics2D. So we use this graphics2D class and draw the chessboard. Like this. We created a for loop inside of this for loop, and here we increase this color one by one, and we draw a square one by one, and we get x and y by multiply color and row by square size, and width and height is square size. And once this color loop is done, then we increase this row by one and then go to the next row. But the point is, the chessboard has two colors, a lighter color and a darker color. So we need to switch colors as drawing squares. So to handle that, so we set two colors on this graphics2D, and these are RGB numbers, so you can choose whatever color you want. And so every time we draw a square, we switch the color. So if it was C0, then we changed this C1. So next time we're gonna draw the square with this color, and the next time this color, and next time this color. Okay, now back to the game panel, and okay, here, and instantiate the board class like this. And from this paint component, we call this draw method. But this draw method receives this graphics 2D, so not graphics. So we need to change this graphics to graphics 2D first, like this. And then we call the draw method in the board class. Okay, let's check if this works. Yep, so it doesn't look correct. So we switch the color every time we draw a square. But the tricky thing is, on the actual chessboard, the color doesn't change when you move on to the next row. And so to handle that, so when this max call loop is done, we go to the next row. So that's when we don't need to change the color. So if we have switched it to, for example, 0, then we reset the change, so she becomes 1 again. So the color doesn't change when we go to the next row. Make sure to place this if statement outside of this for loop. So we only check this when this for loop is done. Let's check. Yeah, now it looks good. So we have succeeded to draw the chessboard. And we're gonna use this blank space to display like game information and stuff like that. Okay, now let's draw the chess pieces. So first we import chess piece images. And if you are using Eclipse, right click on the project and select the new and the source folder and name it res. Then create a package inside and name it piece. And if you are using IntelliJ, right click on the project and select directory and name it res. And right click on the res and select mark directory as, and then select resource root. Make sure it has this resource mark like this. Then create another directory inside the res and name it piece. And to this piece folder, we copy the chess piece images. And I have created these images with Sprite. And I have uploaded them to my itch.io page. So if you want to use these, you can download them. Or you can create on your own or get them from somewhere else. So there are many chess piece images on the internet that you can use for free. So I think it wouldn't be so difficult to find one. And the size of each piece is preferably 100 by 100 each. So it's the same size as the square size in a program. So okay, anyway, let's copy these images to this piece package. Yeah, like this. So now we have these images, we can create pieces. And this time inside of this piece package, create a class and name it piece. And this will be a superclass for all pieces. So it's like a blueprint for every piece. And we set some basic parameters here. Yeah, like this. Pre-call means previous call and previous law. And I'm gonna explain about these a bit later. And the constructor is like this. So we get its color, call, and law. Then we want to get its x and y coordinate on the screen. So yeah, let's handle it with methods because we likely do the calculation a lot during the game. Yep, like this. So this top left, this is 0, 0. So for example, if a piece is on the call 3 square, its x coordinate would be 3 times square size, so 3 times 100. So this x is 300. And if it's call 3 and allow 2 square here, then x is 300 and y is 2 times 100, so y 200, so 300, 200. And having these kind of methods is pretty handy, so since we can easily get its x or y by passing call or allow. And finally we set these call and allow as pre-call and pre-allow. Then we create this getImage method. So we have these piece images, but to use them in a program, we need to import them as buffered image, and that's what we are doing here. So this method receive image path, and based on the path, get an image as buffered image. So let's try this with Pawn. So we create a new class in this piece package and name it Pawn. And this extends piece and at the constructor. And here we can get its image, but I think we should choose its color first. So back to this game panel. So I used integer variables and set 0 is white and 1 is black. And in the game of chess, usually the game starts from white. So I set the current color white. And now here we get an image based on its color. So if this pawn's color is white, we pass the white pawn image path to this getImage method. And it gets it as buffered image and returns it. So yeah, we can receive it here. Alright, so like this, let's create other pieces too. So we create Rook, Knight, Bishop, Queen, and King. Okay, white Rook and black Rook. Knight and Bishop. Yeah, Bishop. Queen. And finally king. Okay, that's everything I think. Now each piece has its own image, so we can draw them on the screen. So go to the game panel and we create two array lists. So these two lists are mostly the same thing. Both will contain the pieces currently on the board. And most of the time we use these sim pieces, and these pieces, just pieces, works as kind of a backup list in case we want to reset the changes that the player made. Anyway, let's add pieces to these lists. And so here we add all the pieces to the list. So these are the pieces for the white team. And now we're gonna copy this and black and change these to black. Like this. We pass its color, call, and allow to the constructor of each piece, so they get their color and default position. And also we call this method probably from here, constructor. Then we create this sim pieces too. Basically we're gonna just copy these pieces and we're gonna handle it with a method because we'll need to do it multiple times during the gameplay. Okay, so here we create a method called so the method receives two lists, and the one is source and the other one is target. And first we clear this target list, then add everything in the source list to the target list. So we're gonna call this method from here and pass these pieces as the source and pass these sim pieces as the target. So we're gonna copy this to this. Now we can draw pieces. Okay, so this paint component. So we scan these sim pieces and draw them one by one. That said, we haven't created a draw method in the piece class, so yeah, let's do it now. So piece class. So we're gonna create a draw method. Like this. Again, we use graphics 2D that we receive from the game panel. Yeah. And draw its image at its x and y, and the width and height is square size. Okay, this should be good, so let's check. Yep, okay. So now all the pieces are on the board. Then next step is moving these pieces with your mouse. So inside of this main package, create a class, and I'm gonna name it mouse class. And this class extends mouse adapter, and we add 4 methods. Yeah, mouse pressed, mouse released, mouse dragged, and mouse moved. So basically these are methods in this mouse adapter, and then also we create some variables. So x and y and boolean pressed, and here. Yeah, so this class detects the player's mouse actions, and if the player presses their mouse button, then set this pressed boolean true. And if the player releases their mouse button, set this boolean false. And this mouse dragged and mouse moved can track the player's mouse movement. So this receives this mouse event as a parameter, and from this E, we can get the player's mouse current position. So we can get them as X and Y, and these two. And that's everything about this mouse class. Go to this game panel, then instantiate this mouse class, and then add mouse motion listener and mouse listener to this game panel. So the program can detect the player's mouse movement or action on this game panel. And also we declare another piece class. So active piece. So we're gonna use this to handle the piece that the player is currently holding. So now let's work on this update method. So first we check if this pressed boolean in this mouse class is true or not. So if the player presses their mouse button on this game panel, what's gonna happen? We want to pick up a piece if the mouse is on one of these pieces. Also, we check if this active P is null. So this means the player is not holding a piece right now. Then we create a for loop. So we scan this sim pieces array list. If one of these pieces has the same color as the current color and also same call as this mouse, so we're gonna get the call by dividing this mouse current x by this square size. So if one of these pieces has same color and the same call and the same row, then that means the player's mouse is on this piece. So the player can pick it up. So we set this piece as active P. Okay. And now, if active P is not null, so this means the player is already holding a piece, so they can move it. So we just call a method named simulate and create this method. I named it simulate because once the player picks up a piece, first we simulate their next move. Any actions taken after this will be hypothetical because it's still in a thinking phase. So maybe the player moves the piece to this square, or maybe capture this piece or something like that. So in any case, the player's next move hasn't been confirmed yet, because they are still thinking. And I found this to be a pretty important concept. Unlike action games such as Super Mario, that everything happens in real time and the player cannot rewind their actions. Chess or any turn-based strategy games have this thinking phase in which hypothetical situations are considered. So our code should be ready for it. So here we update this active P's X and Y based on the player's mouse position. Let's check. So click this. Yeah. So now we can pick up a piece, but right now the mouse pointer is located at the top left corner of the image. So let's adjust it to the center of the image by typing like this. So we just need to subtract a half square size from the mouse X and mouse Y. Okay, so now, yeah, it looks like this. I think this is better. Okay, now we want to update its call and allow to go to this piece class and let's create similar methods. So to get call and allow, usually you just need to divide them by square size. But I added half square size because so this piece X and Y means here. So the top left. In Java, images are handled like that. And so if this piece is around here, then the top left of this piece is on this tile, on this square. So the program considers this piece is on this square. And that doesn't feel correct. So I added a half square size to both X and Y to detect its call and allow based on the center point of the piece. So half square size and half square size. So around here. Okay, then let's go back to the game panel and let's update the active P's call and allow. Yeah, like this. And to check if this is working correctly or not, we draw a little effect on the screen. So the color of the square where the active P is currently on changes. So inside of this paint component, okay, so if the active P is not null, first we set the color on this graphics 2D, and then we change its opacity. So we decrease its alpha to 0.7 and then draw a rectangle and position the x is active P call times square size and y is active P low times square size and the width and height is square size. And finally reset the alpha, otherwise other things will be half transparent too. And after that we draw this active P. Make sure to draw this after this, otherwise this will get covered by this white square. Okay, let's check. Alright, yeah, now looks like this. if you didn't add this half square size, then it will be like this. Yeah, look at this. So it's far from accurate. So that's why we needed to add these half square size. So now we can pick up and move a piece, but you cannot release a piece like this, right? So it should be placed at the center of the square when you release it. So game panel, and in this update, so if the player releases the mouse button when they are holding a piece, so let's update its position. So we're going to create a method in this piece class. So we update its x and y based on its current core and law. So this basically adjusts its position and place it at the center of the square. Also, we update these previous core and the previous law since the move has been confirmed and the piece has moved to a new square. And okay, so go back to the game panel, and here, when the player releases the mouse button, we call this update method and adjust its position, and also make the active P null because the player has released this piece. Okay, let's check. Okay, so yeah, like this. So wherever the player releases the piece, it is placed at the center of the square. But right now the player can move these pieces freely. In the actual game, each piece has its own movement rules and restrictions. So next we're gonna implement them. Okay, so piece class, and first create a blank method. So this receives call and allow, but we don't do anything here. We are gonna override it in each piece class. So now we're gonna work on these pieces, and we're gonna skip pawn for now because it's actually the most complex piece. So let's start from king. And here as well we create the canMove method, and as you can see this method return boolean. And what we check here is we pass a call and allow of a square and check if this king can move to this square. If this king can move to the square, return true, and if cannot, return false. So basically this target call and the target allow is the square that the player is selecting with their mouse. And first we check a very basic condition, that is if the player is pointing a place on the board. If the player's mouse is pointing somewhere outside the board, for example, around this black area or outside the window, then naturally this king cannot move there, so we can just return false. So to check that, go to the piece class and create a method. So if the target call and allow are 0 or greater and 7 or less than 7, that means the square is within the board, so return true, and otherwise return false. So now back to the king class and add this condition. So if targeted square is within the board, maybe this king can move. And next we check if the targeted square is within the king's movement range. And in chess, king can move in all directions by one square. And to check that, okay, where is it? We can use this pre-call and pre-allow. So we check 8 directions. And first we check left, right, up and down. So here's a little math. It looks a bit complicated, but actually not so if you understand the logic. So these pre-call and pre-allow are basically the king's previous position. We subtract them from the target call and the target allow, and this ABS means absolute. So this math.abs gets the result of this calculation as an absolute number. So if this target call is 1 and the pre-call is like 5, then 1 minus 5, so minus 4, but this takes it as 4, just 4. So basically it is a function to get the difference between these two numbers. And we do the same for allow. Then we add the answer of these two calculations and see if the answer is 1 or not. For the answer to be 1, so one of these answers must be 0 and the other must be 1. If both are 0 or one of them are 2 or 3, then you can never get 1. So one of them must be 1 and one of them must be 0. So if you go up by 1 square, the call difference should be 0 and the allow difference should be 1. And if you go left, the call difference should be 1 and the low difference should be 0. And down and right as well. So basically this calculation covers these 4 squares. And next we check these 4 squares. So top left, top right, down left, and down right. And to do that, we add the condition like this. So this time we multiply these answers. And to get 1, both need to be 1. If one of them is 0 or more than 1, we cannot get 1. And which covers these 4 squares. Alright, so let's check if this is working. And so back to the game panel. We add 2 booleans like this. And in this simulate method, first we set these booleans false. And here we can call that canMove method. So we call the canMove method in this active P and pass and this piece current call and allow as the target square. So if this active P is king, it calls this canMove method and check if the king is hovering over a reachable square, and if this returns true, we change these booleans true. And also in this update, when the player released the mouse button, Alright, so if this valid square is true, then we update the position, but if not, that means the piece cannot move, so we should reset the position. And we're gonna create this method inside of this piece class. Okay, here, I think. So to restore the previous position, we can use these pre-call and the pre-allow, and based on them, and we can also reset its x and y. And okay, game panel. And finally, in this paint component, we add this condition. So the square becomes white only when we are selecting a reachable square. And to check this, I think I'm gonna change the king's position a little bit, like 4-4. Okay. Okay, so see. Yeah. So now the king can only move one square, and if you try to move further and release your mouse button, it resets the position. But as you can see, right now it can move even if the target square is occupied. In chess, if the square is occupied by an opponent piece, you can capture it. If the square is occupied by an ally piece, you cannot move there. So let's take care of this. So piece class. And first we need to detect if the active piece is hitting a piece. So let's create a method to check that. Yeah, so it would be like this. So we receive target call and allow, and then scan this sim pieces list and see if there is a piece that has exactly the same call and allow, except this active piece. And if there is, return this piece. Okay, then let's add a piece here, and then we create another method. So first we get this hitting piece by passing this target call and allow. And if there is no hitting P, that means this square is not occupied. So the player can move to this square, so return true. And if the hitting P is not null, the square is occupied. So we need to check this hitting P's color. If the color is different, the player can capture it, so they can still move to this square, so return true. But if it has the same color, the player cannot move to this square. So we set this hitting P null and return false. And now in this king class, we do one more checking. Like this. So if the king can reach this square and the square is confirmed valid, then it can move. This way we can handle the movement properly even if the square is occupied by a piece. Yeah, let's check. So now king cannot move to this square, but can move to this square, or this square, or this square. Okay, then let's remove these captured pieces. So we type like this. Okay, right. So if the hitting P is not null, we remove it from the list. And to remove it, we need its index. So let's find it out. And we can do it here, but I think creating a method will be more handy. So again, in this piece class, something like this. So we scan this sim pieces list. If it's the same piece as this one, then return this index. Okay, so game panel, and here get index. Yeah, so we can remove this hitting P from this list. But this is still simulation phase, so we need to confirm it when the player released this active P. So here, when the mouse button is released and the square is valid, and we're gonna call this copy pieces method we created earlier. So this time we pass this sim pieces as the source and these pieces as the target. So we're gonna copy this to this one. So we apply the changes that happened to this list during the simulation. So this basically means the simulation phase is over. So if a piece has been removed during the simulation, we apply it to this backup list too. And on the other hand, if the player cancels the move, so we restore the original list. Also, even during the simulation, we need to restore the removed piece at the start of every simulation loop. Otherwise, the pieces the player touches will disappear one after another as they move their active piece. So yeah, like this. So we use this backup list and copy it to the sim pieces. Now it should work, so let's check. Yeah. Okay. So now the captured pieces are removed from the board. So we finished implementing the basic rule set of this king. So the next one is, let's take care of knight. Since this is pretty simple. Knight. So again, create this can move and check if it's within the board. Then we check this target square is reachable by this knight. And the knight can move 2 squares vertically and 1 square horizontally, or 2 squares horizontally and 1 square vertically. So the movement ratio is 1 to 2 or 2 to 1 always. So the calculation would be so the answer needs to be 2. And to get 2, the calculation needs to be 1 times 2 or 2 times 1. So one of these needs to be 1 and one of these needs to be 2. So if these core difference and law difference are in such ratio, that's where the knight can reach. Then again, check if the destination square is valid or not. If it's valid, return true. And that's everything. Oops, this is not pre-core but pre-law. Sorry about that. Okay, let's check. Okay. Yeah, looks good. Okay. Then let's take care of this Rook. So Rook. So again, create the can move and check if it's within the board. And Rook can move any number of squares vertically or horizontally. So the next condition would be something like this. So as long as one of these don't change, it can move. If the core is the same, it can move any square on the vertical line. And if the law is the same, it can move any square on the horizontal line, except the same square. So this condition includes the square that the Rook is previously on, but it cannot move to the same square, so we need to exclude it. And to do that, we make another method in this piece class. So create a check method like this. If both target core and target law are the same, return true. So we add the condition here. And then again we check if the targeted square is valid or not. If it's valid, return true. Let's check. So cannot move diagonally. But there is still one problem. As you can see, as long as its target square is valid, it ignores the pieces along the way. So this is not correct. If there is a piece on the line, Rook should stop there. So let's take care of that. So in this piece class, we're gonna create another check method. So create a method like this. And we're gonna check 4 directions. So when the piece is moving to the left or moving to the right, moving up and moving down. Like this. We create a for loop and it starts from pre-call -1. So pre-call -1 means here, because we don't need to check the previous square. And in every loop, we decrease the call. So this C is call. And repeat it. As long as the call is less than the target color. And while doing that, we scan the sim pieces and check if there is a piece on the square. This C and the target allow, because we don't need to change the allow. So if there is a piece to match this condition, that means this piece is on the line. So we set it as the hitting P and return true. And we're gonna take care of the other directions too. So we're gonna just copy this and paste it. And this time we're gonna change it. This is +1. And we increase the call. And also this is less than target call, I think. So it basically is the opposite. And okay, so copy this and paste. And this time it's moving up, so we're gonna check not call but allow. Allow, and this is minus. And yeah, let's change this to R. And okay, so this is target call and this is R, like this. And wait a minute, this is not greater. Yeah, and copy and paste, and this time so moving down, so increase the allow and less than target allow, increase allow, and the rest is the same, I think. And if none of them return true, that means there is no piece on the line, so we return false. Okay, and here look, we're gonna add another condition here, like this. So yeah, let's check. Okay, now okay, so now the Rook can move to this square but not these anymore because the path is blocked. Yeah, looks good. Okay, so king, knight, and rook are done. Next, let's take care of bishop. Bishop. Okay. Okay, again create can move method and check if it's within the board and not the same square. And bishop can move any number of squares diagonally. So we can check that by calculating like this. So basically, if we want to move diagonally, the call difference and allow difference always needs to be equal. If you move here, you move 2 squares horizontally and 2 squares vertically. The ratio is always 1 to 1. So in this if statement, we get the call difference and allow difference and check if they are equal. And if they are equal, we check if the target square is valid. But again, we need to check if there is a piece that is blocking the path. But this time, the path is not straight, but diagonal. So go to the piece class again and create another check method. So we check 4 directions So if the target row is less than the previous row, then the direction should be either up or up left or up right. And if the target row is greater than the previous row, then the destination should be down left or down right. So first we take care of this up left. Again we start from pre-call -1 and decrease the call. So this is the same. Then we get the difference of the currently checking call and the previous call. So then we scan the list and check if there is a piece that has the same call and a row that is equal to the previous row minus this difference. Because the piece is moving diagonally, so moving to the left by 1 square means its row decreases by 1. If it's moving to the up left. So if the condition matches, set it as a hitting P and return true. Okay, yeah. And now upright. So we're gonna just copy this and paste it. And again, this time call +1 and increase the call. And the rest is the same, I think. Oh no, and this one. Less than the target call. And now down left. Copy this. Okay, and this time we're gonna change here plus difference because it is going down, so rest is the same. Yeah, then copy this and paste it, and down right means +1 and plus and also less than the target call. Yeah, that's all. And if none of them returns true, then we return false. So go back to the bishop and we add the condition here. That's it. So let's check. Okay. Yep. Wait. Yeah, you cannot jump this piece like this. Yeah, you cannot jump. Okay, looks good. Now let's take care of queen. So queen. Okay, and queen can move any number of squares vertically, horizontally, and diagonally. So it has the ability of rook and the bishop combined. So the code is also like something, rook and bishop combined. So we check both straight movement and diagonal movement. And if one of them return true, it can move to the target square. Okay, let's check. So, wait, what? Okay, checking queen. And what's going on? Yep. Okay. Valid square, target call, target allow. Oh, this is false. Sorry. This is false. Of course. Ah, my bad. Alright. Now, yeah, okay. Alright. Now it can move vertically, horizontally, and diagonally. And it cannot jump like this. Yep, looks good. Okay. And final piece is pawn. And this is actually the most complicated one. It looks simple enough, but where pawns can move to changes depending on the situation. In normal circumstances, pawn only can move forward by 1 square, but if it's first move, it can also move forward by 2 squares. But pawn cannot move forward if there is a piece in front of it, like this, regardless its color. So it cannot capture it like this. But instead, pawn can move diagonally if there is an opponent piece on the square and capture it. Also, since pawn basically move forward, the moving direction changes depending on the color. So if it's white, it moves upward, and if it's black, it moves downward. So we need to take care of that direction element as well. So pawn class. So this part is the same, and then we check its color and set the direction it moves to. Yeah, like this. So if the color is white, it's going up, so the move value is -1. And if it's black, the move value is 1 plus 1. Then, unlike other pieces, we get the hitting P here. The reason is we cannot use this valid square method for pawns because pawn cannot move forward if there is a piece in front of it. So hitting a piece doesn't necessarily mean the pawn can capture it. So we handle this a bit differently here. So first, 1 square forward movement. So if the call is the same and the target allow is pre-allow plus 1 or -1, so depending on this move value, and hitting P is null, then it can move to this square. Let's check. So yeah, like this, but it cannot move like this. Yeah, then 2 squares movement, and to check this, first we need to know if this piece has moved previously or not. So we're gonna create boolean in this piece class, and then go to this update position method. We add this. So when update the position of a piece, set this true. So we can know this piece has moved at least once. So back to the pawn. So the condition would be like this. So we multiply this move value by 2 because it's moving by 2 squares, and it can be done only when this moved boolean is false. And this time as well we check if a piece is on the path. Otherwise, the pawn can jump over a piece. Okay, let's check. So now, yeah, so if it's first moved, then it can move 2 squares or 1 square. You can choose, but it cannot jump over a piece like this. Okay, looks good. And okay, next, capturing pieces. Okay, so when a pawn can capture a piece, it moves to the left or right by 1 square. So the core difference needs to be 1, and target allow needs to be pre-allow plus 1 or minus 1. And if it is hitting a piece, and if the piece color is not the same color, then it can move and capture it. Yeah, check this. And now it cannot move this way, but can move this way, like this, not this way. Yep. Looks good. Okay. Okay, so now the basic movement of all the pieces have been implemented. So there are still some exceptions left, such as Catherine or Passant, but we take care of them a bit later. For now, let's continue to implement the core game mechanics. So back to the game panel, and next let's change the turn. But right now we can only move the white pieces, but let's switch the turn once the player confirms their action. And maybe somewhere around here. Okay, yeah, create a method like this. So if the current color is white, then change it to black, and if it's black, then change to white, and make the active P null. Okay, then call this method from inside of this update. So when mouse button released and move confirmed, here I think. Okay, let's check. So okay, now yeah, you cannot pick up the white piece, but so it's black down now. Yeah, like this. So now the game progresses with changing turns like this. And I think it's a good idea to display a text so we know which turn it is now. So in this paint component, we set some text info on this graphics 2D. Okay, so first set anti-aliasing, and yeah, set the font. I chose Book Antiqua, but you can pick any font you want as long as it's in your computer. Then choose font color, so I chose white. Okay, then display a message. this. So depending on the current color, we display a different message. Okay, let's check. So now white's turn, black's turn, white's turn, black's turn. So I think now we are ready to implement other exceptional actions. There are 3 special actions in chess: castling, passant, and promotion. Okay, first, castling. This can be done with king and rook. Okay, so here's chess Wikipedia. Castling, yeah, here. So once per game, each king can make a move known as castling. Castling consists of moving the king 2 squares toward a rook of the same color on the same rank, and then placing the rook on the square that the king crossed. And to implement this, first we declare another piece in this game panel, castling P. And we don't need to do anything with rook class. We handle it in this king class. So first we check if the king has moved or not. If the king has moved, we cannot do the castling. And there are 2 castlings, so right castling and left castling. So the castling is basically switching the position of king and the rook. So if it's king's first move and there are no pieces between king and the rook, okay, let me create the situation. So if it's the king's first move and if there is no piece between king and the rook, then king can move 2 squares to the right or to the left. So king can move here and rook move here or move here, I think. So there are 2 castling. So if it's the right castling, so in that case the target square needs to be call +2 and on the same law. And we also check if there is a piece on the path. Then yeah, like this, and okay, not visible. Not, it's public. Okay, alright. Then public piece, castling P. Let's change that. And also static, I think. Static. So we scan sim pieces, and if there is a piece that is 3 squares to the right on the same law and hasn't moved. If it hasn't moved, that means this is rook, because this is its starting position. King plus 1, 2, 3. So we get this piece as the castling P and return true. Then left castling. And this is a bit more tricky, since we need to check not only if the king can move to this square, but also if this square is vacant. If a knight or any other piece is on this square, the castling cannot be done. So, and to check the situation, we use an array and create a loop like this. So scan the sim pieces, And if there is a piece with core -3 and the same law, so -3, 1, 2, 3 here, then put the piece in the slot 0. And if there is a piece with core -4 and the same square, 1, 2, 3, 4, so this one, then put it in the slot 1. Then so to do the castling, so P0, this is a knight position, needs to be null. And the piece in the slot 1 needs to be at its starting position because it needs to be Rook. So if these conditions are matched, then there is no piece on this square and Rook on this square. So we can return true. Then go to the game panel. And now in this game panel, we create a method called somewhere around here. Check castling and type like this. Like this. So the castling piece core is 0. That means it's a Rook on the left, and in that case the Rook moves by 3 squares, 1, 2, 3. And if the core is 7, then it's a Rook on the right and it moves 2 squares. So the movement value is different depending on the direction. So yeah, that makes it a little bit complicated. And after that we update this castling piece to X based on the updated to this core. And then so we're gonna call this method during this simulation. So here, so we can simulate the movement on the screen. Also, we reset this movement at the start of every loop. Otherwise, the moved Rook remains on the same square even after the player cancelled the castling by moving the king somewhere else. And also, when the player releases the mouse button and confirm their action, we update the castling piece position like this. So now castling should work. So let's check. Yeah, like this. Oops. What? Null pointer. Oh, wait. Oh, okay. I think first we check if this is null or not. Not equal null. And okay. Alright. Yeah. Okay, sorry about that. So we needed to check if this P1 is null or not, otherwise we get null pointer exception. So left castling, also right castling. So the castling is also done. And the next is Passant. So this is an unique move by pawn. So when a pawn makes a two-step advance from its starting position and there is an opponent's pawn on a square next to the destination square on an adjacent file, then the opponent's pawn can capture it in passant, in passing. So moving to the square the pawn passed over. This can be done only on the turn immediately following the enemy pawn's two square advance, so this is important. Otherwise, the right to do so is forfeited. For example, in the animation diagram, the black pawn advances 2 square from g7 to g5, and the white pawn on f5 can take it en passant on g6, but only immediately after the black pawn's advance. Yeah, a little bit complicated. So if a white pawn is here, and if a black pawn does a two-step movement like this, then this white pawn can capture it, moving like this. So if it's immediately after the black pawn did the two square movement, and that's what we're gonna implement. So let's go to the pawn. So yeah, there are some conditions that we need to handle. It's pretty tricky, especially this one. So we need to know if the piece did two square advance during the previous turn. Okay, so first go to the piece and create another boolean. So we have the boolean like this, and also we need to know if the piece is pawn or not. And to check if it's pawn or not, we add kind of an ID to each piece. So we can handle this with integer as well, but I think enum is pretty handy for stuff like this. So right click on this main package and create enum and name it type. And what we do is very simple. Just input piece types here like this. And that's everything about this enum. Go to the piece, and here we add this type here, this one from this main package. Then add the type to each piece so we can use it as its ID. So like this, type equal type dot pawn. Rook, knight. Yep, like this. And okay, piece class, and now inside of this update position, so when we update the piece position, we check if the piece is pawn or not. And if it's pawn, we check if the row difference is 2. If so, it moved by 2 squares, so 2 stepped becomes true. But this true state should only be available for a turn. So when we change the player, we also set it false. So change player here. So if we are switching to black, then we scan the list and find the black piece and disable all the black pieces, this two-step boolean to false. And if you are switching to white, then you're gonna disable all the white pieces, two-step movement. Okay, then go back to the pawn class, and so en passant is basically diagonal movement, and so we can copy this condition, but we are not hitting any piece, so we don't include these conditions. So we scan the list, and if there is a piece that its call is equal to the target call, because in this case, yeah, call should be equal, and its law is equal to the pre-law, because in this case, this black piece is on the same law of this white piece previous position. And if this piece, the two-step movement is true, so that means this piece just moved by 2 squares in the previous term, then we can make en passant action. So get this piece as hitting P and return true. Okay, yeah, let's check. So yeah, move these, move these, move these, move 2 squares, and then we can capture this square and move like this. Move these, and yeah, this black can capture this white piece like this. So that's the en passant. And finally, the promotion. When the pawn reaches the farthest square or farthest law, so if you are white, then so here, and if you are black, then here, then the pawn can be promoted and can be or must be exchanged to either queen, rook, bishop, or knight, and the player can choose which one. So most of the time, queen is their first choice since it's the strongest piece, but you can still choose. So let's implement it. So inside of this game panel, first we create another piece array and the boolean too. Then create a method. Yeah, like this, can promote. And first we check if the piece is pawn, so yeah, like this. Then its position based on its color. So if it's a white piece, check if its law is 0. And if it's black piece, then check if its law is 7. And if so, we can display the icons of 4 candidates around here, so the player can click one of them. And to do that, first we add pieces to the promo pieces list that we declared earlier. Yeah, like this. So positions are like core 9, Lao 2. So core 9 means this is 7, so 8, 9, and Lao 2, 3, 4, 5, so somewhere around here. And so we add these 4 pieces to this promo pieces list, and then okay, so when the player confirm their action, so call the method. So before changing the player, so if can promote, and if this returns true, then promotion call true, and else then we can change the player. Okay, at the start of this update, we check if this promotion boolean is true, and put everything this inside of this else bracket. Yeah, so during this promotion we basically stop the game, So you cannot pick other pieces until you finish this promotion process. And here, so we call a method promoting and create this method. But before working on this method, let's display those 4 candidates on the screen. Go to the paint component. Okay, so like this. So we scan the promo pieces list and draw the image one by one. So piece image, and we get the X and Y coordinate and image size. Okay, let's set up a situation, sample situation, so we can easily test it. Yeah, like this, and call this. Instead of this one, K. Yeah. So, oh, black stan. Okay, we need a black pawn too. So 3 or something. Okay, so promotion. Okay. I want to disable this. Else. So during the promotion, we don't want to display this text. So okay, yeah, like this. And next, we want to select one of these. So now, in this promoting, first we check if the mouse button is pressed. And if there is a piece that has the same call and allow as mouse call and allow, and that means the mouse is on one of these pieces, so we can pick it up or select it. And so create a switch like this and check the type, and if it's Rook, add a Rook to these same pieces, and so on. And once the player select one of them, so we pass this active piece call and allow as its default position. After that, we remove the active P, which is pawn, from this list. And then the list has changed, so we copy these same pieces to these pieces, so we update this backup list as well. Then make this active P null and promotion false, and call the change player. Okay. Promotion, and okay, let's choose bishop. Yeah, so now bishop is here. And okay, so bishop, so now bishop promotion. Let's choose, I don't know, queen. Yeah, so queen is here now. Yeah, so now pawns can promote to a different piece. And the next is checking king's illegal movement. So king is a special piece, so if it is captured, you lose the game. So if you are trying to move your king to a square that is reachable by opponent's piece, the move is considered illegal. because we already know that the king will be captured in the next turn. So we need to detect such moves. So in this game panel, first create a method like this. Then type like this. Yep, like this. And call this during this simulation. So we pass the active P to this method and receive it and check if it's king or not. And if it is king, scan the sim pieces and check if there is a piece that is not king itself and has a different color and can move to the square where the king is trying to move now. And if these conditions are matched, this move is illegal because the king will be captured in the next turn. So to consider this square is valid, then we need to clear this checking. And to make it easier to see, so let's change the square color when the move is illegal. Paint component again. Okay, so if it's illegal, we're gonna use gray color. Okay, let me create another sample situation. Okay, let's check. So now these squares are considered illegal because the black queen will surely capture the king. And okay, this and the black queen is here. And okay, even if you capture the black queen, the king will be captured by the black bishop. So this move is also illegal. Actually, this is already checkmate, I think. Yeah, so now we can handle the illegal situations as well. We are getting closer to the end, I think. And now let's take care of probably the most complicated part in this video, in this tutorial. So detecting check and checkmate. Okay, first we add another piece object and name it checking P, and also another boolean game over. Okay, then inside the update, when the player confirmed their move, we check if the opponent king is in check or not. Here, and put these in this else bracket like this. So create a method. And so we need to get the king, and to get the king we create a method. So this method finds the king in the sim pieces and return it. And I set this parameter opponent. So if this is true, return the opponent king, and if this is false, return your own king. So depending on what you want, opponent. If it's opponent, then we check if its color is not the current color. And so here we call it and get the king. So we want to get the opponent king, so pass true here. Then we check if the active piece can move to the square where the opponent king is. And if it can, this piece is checking the king, so set it as checking P and return true because the king is in check. And if not, checking P is null and return false. And so yeah, and what is key? I lower letter. Okay, we'll handle this later. We still need to check checkmate to see if this is game over or not. And I think it would be better if you see a message when the king is in check. So let's do that. Again, this paint component. So status message. And okay, here, I think. So if checking P is not null and the color is black, then we're gonna display this text. The king is in check in red color. And okay, so if it's black's turn, then copy this and paste. And so this white. And okay, change the position. Let's check. So white turn cannot move. And okay, so let's check the king. Oh, what? Why? Ah, okay, I see. Yeah, because so right now we are only checking this king in check. So if this is true, then program stops here and it's not gonna check these. What should I do? Okay, for now, let me disable this and yeah, so remove this else bracket so we can still process these things too. Just for now, we'll fix it a bit later. Okay, let me check. Okay, so yeah, the king is in check. Okay. So detecting check is established now, and here there is one more thing we need to take care of. In chess, if your king is in check, you have to counter the situation. You cannot move other piece to a place like this because it's obvious that your king will be captured in the next turn. So this kind of action is also considered illegal. So we need to detect such moves as well. And to detect that, we create a method. Like this. So this time we get not the opponent king, but the current color's king. So pass false. And we scan the list and check if there is a piece that can move to the king's square. So it looks kind of similar to this. It's illegal. And call this during the simulation. So here. So we check both illegal and opponent can capture king, and also print component as well, and here as well. So if the king's move is illegal or the opponent can capture the king in the next turn, then the square becomes gray. Let's check. White's turn. And now the king is in check, and if you try to move this pawn like this, then it is considered illegal because you will lose your king. Okay, then we're gonna detect checkmate, and this is the hardest one. So when a king is in check, we calculate all the possible moves that can be done by the checked king's side, in this case white team, and if we confirm that there is no way to escape from the attack, then we declare checkmate and the game is over. And to know this, we need to check 3 possibilities. And 1, if the king can move to a square where it is not under attack. And 2, if the king can capture the checking piece. And 3, if one of the king's ally can be placed between the attacker and the king and block the attack. And we create 3 methods to check these. Like this. First we check if the king in check can move to a square where it is not under attack. And the king can move to 8 directions. So we need to check them one by one. So we check it with this king can move method. And this method receives a king as parameter, and then call this is valid move method like this. So we pass king and the call plus and allow plus and simulate all the moves. -1 means here, so call 0 -1 means this one. So we check all the directions and check if it's a valid move or not. And if this returns true, that means the king can move to this direction, so return true. And if none of them returns true, that means there is no square that the king can move, so return false. So let's work on his valid move method. So first we add these call plus and allow plus. So we basically temporarily update this king's position and check if this is a safe spot or not. So first we check if this king can move to this square, so this square, and if he can, check if it's hitting any piece, and if it is, remove it from the list. Then check if the move is illegal or not. So basically we are doing the king's usual stuff, but with these hypothetical position. If the king can move to this square and the move is not illegal, then this is a safe spot. So make this boolean true. Then after that, reset the king's position. Also reset the piece list, because we need to simulate all these directions. So we cannot keep adding these values to this king's position. We need to reset it every time. And also maybe we have removed a piece from the list, so before checking other directions we need to reset the list as well. So these two methods are done, and now work on this. It's checkmate, and this method return true as default. So first we get the opponent king. Then call this king can move and pass the opponent king. So we can check if this opponent king can move any of these directions. And if this returns true, that means this king can escape. So this is not checkmate yet. So return false. This is not checkmate. But this doesn't return true else. So that means there is no square that the king can move to. But this is not over yet. So check if the player can block the attack with their piece. And to find it out, we first determine how far away the attacking piece is from the king. So in this case, this queen is 1, 2, 3 squares away from the king. Yeah, so like this we get the call difference and allow difference between checking piece and the king. Then, using this information, we find out if we can move a piece into a square between the attacking piece and the king. So in this case, this square or this square. And to do that, we need to find out the attacking path. So maybe the attacker is attacking from above or below or left or right. So we need to find out. So if the checking piece has the same call, so that means it is just above or below the king. And if it has the same law, it's placed to the left or to the right of the king. And if the call difference and the law difference are the same, that means it is attacking diagonally. And if none of them are applied, that means the checking piece is knight. Okay, and now if it is attacking vertically, we check if it's from above the king or below the king. Yeah, like this. Then we create a for loop and check if we can place a piece between them. Okay, so in this case the checking piece is above the king, so like this. And in this for loop we start from the checking piece law, so in this case here, and increase the law one by one, while the law is less than king's law. And while doing that, we scan the sim pieces and check if any of the king's piece. So king is the opponent, so we check, so it's not king, and the color is not current color, and if the piece can move to this square, currently checking the square. And if we could find such a piece, that means this piece can block the attack, so block the path. So this is not checkmate yet. So return false. And we can do the same for other direction. So copy this. And this time greater. So it's from below, and also this one minus. So yeah, this time the attacking direction is opposite. So start from the checking P and decrease the low. So now when the checking piece is attacking horizontally, and so we check call this time, and I think we can copy this, and this time so call 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 and call, and this is call and checking p dot low. Yeah, like this. And so the opposite, if it's to the right, then this time less and minus, and the rest is the same. And finally this diagonal situation, and this is kind of a mix of these two. So we check two conditions: either the attacking piece is above or below the king, and if the attacking piece is to the left or to the right of the king. Like this. So there are four possibilities: upper left, upper right, lower left, or lower right. And for the upper left case, so this time we check both call and low. So increase call and low because it's diagonal. And then like this, if there is a piece, it is not the king and not the same color and can move to this location, so checking square, then yeah, return true. No, return not true, false, sorry. Alright, then upper right, just copy, paste, change this, and minus, minus. No, call is plus because, yeah, because the checking piece is above the king. And this is okay, so yeah, let's do this. Lower left, copy this, paste it, and lower left means plus plus and low minus minus, and the rest is okay, I think. And the lower right is minus 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 minus, and that's everything, I think. Yeah. And for this knight, actually we don't need this, so you can remove it if you want, because knight's attack cannot be blocked with other piece, because you know it's a kind of jumping attack, so you cannot block it. So this method is also done. Also done. So we can finally detect checkmate. Alright, so back to here. So now we can add another condition here, is checkmate. And so if both of them are true, then this is game over. And then, okay, we can restore this else statement, else bracket, and remove this. Yeah, if it's not checkmate, then it's not game over yet, so we can, you know, continue the game. So and also if it's game over, we stop all the update. So change this condition to else if game over false. And let's display the text when the game is over. Yeah, like this. This time I chose Arial font and also green color. Okay, let's check. So white term, what to do? Okay, like this, and this should be checkmate. So yeah, black wins. Okay, so checkmate is detected, and now the final touch. We implement stalemate, and then this tutorial will be done. So stalemate happens when a player is not in check but has no legal move left. Okay, I'm gonna show you an example. Yeah, so like this, and if you move the queen like here, now the black king is not in check and has no place to go. Illegal, 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 illegal. So nothing to do. And this is stalemate. And this is considered draw in chess. I don't know why, but looks like this is white's win. But in chess, it is considered draw. So let's detect stalemate. And it's actually not that difficult. And so first we're gonna add final boolean stalemate, and create a method. Then count the number of pieces of the opponent, because stalemate only happens when you have one piece left, which is king. If you have other pieces, you can move them, so stalemate doesn't happen. So we count the number, and so if the count is 1, which means only the king is left. And then we call this king can move method, this one, and pass the opponent king. And you know, if it returns false, that means there is no square to move for this king. So it's stalemate, so return true. But if the king is in check, this doesn't happen, so we add the condition. So here, else if is stalemate, then we change this boolean to true. So stalemate is basically game over, so we're gonna add the condition here, stalemate call false. And also let's display a text. So paint component and so copy this and stalemate light gray or something. Yep, that's it. So let's check. Okay, move here, stalemate. Okay, so that's everything. Actually, there are still some minor rules that we haven't implemented, but I think this is good enough to enjoy the game normally. Yeah, so coding chess was way more complicated than I thought. Of course, this is not the only way, so I'm pretty sure there are many other ways to do this, but still, chess is, yeah, pretty complicated. But I enjoy the process of understanding how it works and putting the code together. So I hope you enjoyed it as well. Anyway, that's it for now. As always, thanks for watching another long video. Yeah, and have a nice winter. Bye.